Hello again. Today we are going to be talking about what stars really are and what a black hole really is. It's pretty cool. I enjoy it. So, the perspective of energy I'm offering comes from the logic of the seven principles found on the Kybalion. If you don't know what that is, there's seven laws of nature that explain how everything works. This interpretation that I'm offering is not Hermetic. In case you're wondering, those of you guys are out there, I do not agree with the Hermetic interpretation. Just the seven principles themselves. So in order to understand what a star is, first you have to understand that everything works through opposites. For example, outward moving light would have, its opposite would be inward moving dark. Now all males have an outward property, so that makes light male. And all females have an inward property, so that makes dark energy female. And they come together to form atoms. Since light carries heat, it is logical to assume that dark energy must be cold. Otherwise, the heat inside the nucleus would eventually burn the atom up. The two opposites keep each other in balance. So this is the correct atomic model. This model has nothing to do with nature. It's incorrect. Man, it's a shame we've been using it for such a long time. So I've moved past it, but if you want to check out those videos about it, you can, or you can read this website that I'm going to be reading from. It's called the Kybalion Physics.com. So I'll be reading directly off of there. Now again, one more thing I should mention about dark energy before we continue is what inward parts really are. So inward parts are tiny measurements of the dark energy that surround the nucleus of an atom. The more inward parts an atom has, the denser that type of matter is, generally. This is shown in the periodic table. The nucleus of an atom can be any size, but because of the rule of opposites, the size of an inward part is constant. Hydrogen is the smallest type of atom and the first element in the periodic table. It has one inward part surrounding the nucleus. Helium has two inward parts. The periodic table shows us that an atom may have up to two inward parts in the immediate orbit around the nucleus and 8 in the second layer or shell. And currently we call these valence shells. As they pile on each other, there is more area to cover, so it allows for more inward parts. So that's the definition of inward parts. I argue they do cause mass or matter, not electrons. If you want to know what electrons are, you have to look in that website again and go to part 4, balancing energy, and it explains it pretty well there. But we're going to go ahead and jump over to part 3, giant atoms. I've been very excited to make this video because I just think it's freaking cool. So let's start with the sun. The sun is the largest celestial body in our solar system. All the major planets in our solar system revolve around the sun. The sun is a star which emits an enormous amount of heat and light. It is already known that stars can be any size. In fact, there are stars that dwarf the size of our entire solar system. Currently, it is believed that the sun is a hydrogen reactor or even a giant ball of gas. But based on what we know from watching hydrogen bombs or gas explode, the sun would have exploded upon ignition. Also, the current studies of the sun tend to ignore the darkness we can observe in sunspots. Sunspots reveal the dark energy beneath the surface of the sun. There is absolute darkness beneath the brightest object in our sky. NASA spots giant hole over the sun was the headline from the American Fox News channel on July 30th, 2013, as reported by NASA. This is the image that was reported to show a hole in the sun, but it actually showed the dark inward energy underneath the brightness of the sun. If space were somehow gray, we would see that the darkness underneath the surface of the sun is still dark. So, the sun is a giant atom. The sun's nucleus would be billions of times bigger than an atom's. Although how large it is a math problem. This project does not do math. It's all logic, no math, sorry. The massive amount of inward parts a star has do not crush the nucleus because masculine and feminine energy come together to create, not destroy. Although it does not appear to be spinning fast, the sun also travels a great distance around the galactic center. The outward motion of spinning and traveling causes the inward energy to be pulled outward, as explained by centrifugal force. Centrifugal force is when an object is spun, it gets pulled outward. Spinning causes an outward force. The outward force caused by spinning can be observed in centrifuge machines and can be felt by spinning around with your arms outstretched really fast, which becomes painful. Inward energy gets pulled outward by centrifugal force. How fast it needs to spin to be pulled outward is, again, a math problem. The faster the spin, the stronger the outward force is. Therefore, stars that spin faster produce more light. Eventually, centrifugal force will break down the enormous atoms, which would then release all the excited heat and light within the nucleus. This does mean that the sun was bigger when it first ignited and has slowly shrunk over time. Currently, quantum physics has labeled a neutron star as a tiny star about the size of a school bus that shines brighter than larger stars like our sun. A supernova is described as the death of a star, releasing all outward force in a massive explosion. Stars are giant atoms that spin and travel fast enough to ignite, getting smaller until they completely combust. The sun, our star, is on the outside of the galaxy. It has a very wide orbit around the galactic center. This incredibly long orbit plus the spin is enough outward movement to pull the dark inward parts into outward energy, which is the cause of every star's brightness. Stars orbit their galactic center the same way planets orbit stars. As above, so below. At the center of every galaxy is an even larger celestial body. Now, before we go on to black holes, I do want to read something more about stars that's mentioned in Part 5, Balancing Energy in Action. Just one little paragraph. Many different types of atoms have been detected on the surface of the sun. This is no surprise, as there are countless inward parts interacting with light. Light and dark form atoms, simple and complex, which get split up again. All this happens on the surface, not inside the sun. Cool, right? So going on about black holes. The first image of a black hole was created in 1979 by the artist Jean-Pierre Lumière. He used an early transistor computer to plot the stars, and then he drew the dots. It most certainly looks like a gargantuan black body, an incredibly large atom, surrounded by many stars. This is a recreation of that image. Mr. Lumière's drawing is far more spectacular. A galaxy is a collection of stars swirling around an even bigger celestial body. The fact that stars spin in orbit around the galactic center would imply that there is something in the middle of each galaxy with an even bigger nucleus of light than what stars have. It has been labeled a black hole. A black hole, like the sun, is an even larger atom. It is the largest atom in a galaxy that all stars rotate around. It is not moving fast enough to ignite, so it stays in its primordial state, a black body. In case you're wondering about gravity and the two forces that keep these bodies at work separate but together is attraction and repel, the two opposites. It's not anything too complicated. So before we go on to what a black hole really is, you do have to understand what balancing energy is, and balancing energy is produced if an atom is unbalanced. So we'll jump over to section 4, balancing energy, and we're reading off of the correct atomic model. The atomic model provided by the logic of the laws of nature explains how an atom works. It is one singularity of outward moving heat and light surrounded by inward moving dark energy. If there is a need for balance, balancing energy emerges. Simple, right? If the nucleus is stronger than the inward parts surrounding it, then excess heat and light are released through balancing energy. This is electricity. So again, electrons come from the nucleus, they don't come from dark energy or the surrounding dark energy. This is the part that's important. If the nucleus is weaker, then balancing energy can carry in heat and light into the nucleus. This is magnetism. As we know, if you put heat on magnets, they lose their magnetism because the atoms become balanced. So that's the definition of magnetism. It hasn't been given by quantum physics, believe it or not. It's so simple. So let's move on over to the end of Part 5, Balancing Energy in Action, and where I finally talk about what a black hole really is after understanding what balancing energy is. A black hole is one giant magnetic atom. Again, if space were gray, we would see a gargantuan black body. There is such a large body in the center of every galaxy. Just like an atom, its nucleus is made of heat and light, surrounded by many inward parts. Despite its massive size, its nucleus remains relatively small, but bigger than what stars would have because smaller bodies orbit larger ones. The immense weight inside such a large body is caused by the massive amounts of inward parts pushing against the nucleus. The reason the nucleus will not collapse despite the pressure of so many inward parts surrounding it is because masculine and feminine energy come together to create, not destroy. The balancing energy produced would try to help by bringing in heat and light into the nucleus. This is the definition of magnetism. It is already known that black holes, or more appropriately named black bodies, suck in heat and light. This is the reason why. Cool. So there you have it. A black hole is one giant magnetic atom. Cool. There's nothing crazy going on in the nucleus. They don't go through other dimensions or alternate dimensions. I don't know what quantum physics has been preaching, man. They lost it. Hamstring, but whatever. You can read about my arguments against quantum physics in part 6, the Kybalion versus quantum physics. And yeah, there's a very irrational and illogical, but it's okay, at least you're being presented with logic and an explanation that we can all understand, which is the purpose of science. So thank you for your time. If you're interested in the website, go ahead and continue reading it on KybalionandPhysics.com. At the bottom of the website, there's a link to buy the book from blurb.com. It's where I made the book, if you're interested in owning a copy. If not, the information is still there for you for free. Thank you so much for your time. God bless you. Have a great day.